So if the radius of nitrogen is 0.71 and the radius of sulfur is 1.05. So notice up here in the problem that they say in the sulfur ring where it's all sulfur, the bond length is 2.05. Well, if you were simply basing it on the size of each sulfur atom and each sulfur atom was 1.05, then you might expect that to be 2.10. Well, it's not. It's slightly less, right? This is less than 2.10. So I guess what you need to assume from that is that all bond lengths will be slightly less than the radius of each atom. Right, we're simply using the radius as an approximation. So if in the S8 ring, which is going to have this hexagonal shape, like I drew in the other ones, if these bonds were less than 2.1, which is less than the sum of 1.05, then if it's a sulfur to nitrogen bond, this will be less than 1.05 plus 0.71, so it's going to be less than 1.76. And I guess technically 1.75 is less than 1.6, but 1.8 is not less than 1.76. So if it's going to be slightly less than the sum of the atomic radii, then I think your best choice is 1.60 to 1.65 angstroms.